Okay, let's get started formally for our lecture number one, week number 10, right? And we'll be continuing our discussion on inheritance. We just had some preliminary introduction to what it is, right? We had not written any program or we had not seen the low level details. So today we'll be doing that. But before that, just to recall you that what we were doing and what is the concept of inheritance, right? So last time we discussed that inheritance actually has the same interpretation in programming, more or less similar to what you have in the real world, right? That you inherit something from your forefathers, right? So things are inherited from one generation to another generation, right? In case of programming, what you inherit, there is nothing materialistic. So basically, we are dealing with classes. So class has only two components: data and function. So when you are talking about inheritance in the context of programming, one class can inherit data and function from another class, right? So this was the general idea, and we said that just like composition is has a relationship, right? This was basically once we studied composition. So similarly, in case of inheritance, we discussed that inheritance is generally called is a relationship. And why we are using this terminology, because if you remember we said that you have something generic, right? For example, I think we had done example of a vehicle, and then you have something specific like a sports car or a family car or a cargo truck, right? So every sports car is also a vehicle, every family car is also a vehicle, right? Because all the properties that you expect from a vehicle, they are present in a sports car as well as a family car. Inheritance is represented by an arrow. An arrow is pointing from the child to the parent, right? So this is the parent class. We use this terminology, and these are the child classes. So this was just a general idea that in case of inheritance, basically your parent class is more generic, and as you do inheritance, you have specific types, right? So we had done other examples like, for example, a student. What are the types of student in a university? Undergrad, postgrad, right? Within undergrad you can have further categories: management science student, computer science student, and so on, right? So once you are doing inheritance, you are going from something generic to something more specific, right? And maybe just to see one more concrete example from the perspective of classes, that we said, okay, maybe we can have a class like employee, and every employee will have some ID which is assigned by the organization. Every employee will have some name, right? And then we say, okay, there are two types of employees in the organization. One is the permanent employees, right? And another type of employees is the daily wages, who are paid daily, right? So permanent employees will have a monthly salary, okay, because they are paid at the end of the month. Daily wages employee, they actually are paid on per hour basis, right? For example, if someone is working 3 hours, so they say, okay, for 1 hour I'll pay you maybe $20. So they simply multiply their per hour salary by the number of hours, and they compute the salary, right? So maybe for this we need to know how many hours this person is working, and what is the salary or rate per hour, right? So once you do inheritance, what actually happens is that you say, okay, employee is my parent class, right? And there are two child classes, permanent employee and daily wages. So what happens is that now all of these two attributes also become a part of permanent employee. These two attributes also become a part of this, right? They are inherited by the child classes. So the advantage is reuse. Rather than having ID and name here separately, as well as ID and name here separately, we just put them once in the parent class, and they are inherited in both or even more than two child classes, right? So the key idea of inheritance is that we should be able to reuse a class as much as possible, right? So now with that, maybe we do a concrete example so that we get this idea. So let me go back to the slides where we discuss a concrete example, right? So this is the very common example that we have been, you can say, working with since the beginning of the semester, right? So again, the same class, the point class, which has two data members x and y. Then we have a constructor, right? Then you have the set functions and the get functions for x and y, and then you have a print function, right? So now you see this is a point in a two-dimensional space, x and y. Okay, so if you have any point in a two-dimensional space, you can use this class and you can actually make the objects of this class. But you see, we can also have a situation where we want points in a three-dimensional space where you have x, y, as well as z. So it means that if my situation is something like where I need points in 3D, so I also need a third data member, which is z. Okay, so if I want to make another class point 3D, okay, just I have given it a different name so that we don't mix it up with the point class. Now it has three data members x, y, and z because we are talking about a point in three-dimensional space, so we have three axes. Okay, so now the constructor will have three arguments, right? It has three data members, so it has a set get function for x, for y, for z, and you can also make a print function. Okay, now let's compare both of these classes on a single slide to see are there any common parts in these two classes. Okay, so you see on the left side you see the point class, and on the right side you see the point 3D class. So if we carefully see it, there's a lot of repetition in point 3D class of what you already have in the point class. Okay, so let me just highlight it. So now you see uh, we have two data members x, y here, which are again repeated here. Okay. Similarly for x and y, you have set and get functions here, which we are repeating here. Okay. Of course, this is the different part because this data member z and set z, get z, these are the you can say additional functions which are present in point 3D. Similarly, the constructor is also different here. The constructor will take two inputs here. The constructor is taking three inputs. Now the idea is that can we somehow reuse the point class, okay, so that we don't have to repeat this part again in the 3D class, point 3D class, okay. So the way to reuse is actually to do inheritance, okay. So now let's see how we can reuse this class with a concrete example, the same example, right? And then we'll write our first program on that, okay. So let me quickly write the class point. Okay, I'll not be writing the body of the function just to save time. Okay, I'll just put their prototypes. So we have two data members, int x and int y, and then within the class we have its constructor. Okay, I'm just writing the prototype to save some time. Similarly, you have a print function, and you have maybe set get function for x, set get functions for y. Okay, you can assume they are there. Okay, so we already have this class available to us. Now we'll be making the class point 3D. Okay, and what do we need is that, okay, this is my point class. I already have x, y, and a lot of function here. Now I'm making another class which we are calling point 3D. What do we want in this class? X, y, and z. But we say since x and y are already present here, so instead of writing them here, I can exploit the concept of inheritance, and I can say that this point is parent, and I can make it a child class. So everything which is here, I will inherit it. It will become a part of my child class, right? So in diagram, we represent inheritance by this arrow, but how do we represent it in the syntax? Let's go back to the program. So I'm making the class point 3D. Okay, I want to tell my program that the parent of this class is actually point class. And how do we do that? Okay, please see carefully. I put a colon here, and this time it is a single colon. Okay, it is not double colon, which is scope resolution operator. It is single colon. After that, we put an access specifier like public or private, right? But for the time being, Maybe in the initial example, I am just fixing it to public. I will tell you later what will happen if I change it. Okay, but for the initial few examples, at least for today, just assume we write public here. Okay, tomorrow I'll explain why we are writing public here. Okay, so for the time being, you can ignore it. You can just trust me that okay, we write public here, and then here you have to write the name of the parent. So what is the parent? The name of the parent is point. And here now we'll try to fill this class. Okay, so let me just explain it again that what we did. You see, till here it is the normal syntax. Whenever you make a class, you write the keyword class and name of the class. Since we are doing inheritance, so we need to tell what is the parent of this class point3d. Okay, it means we are changing something in the child. We are not doing anything in the parent class. Parent class stays as it is. Okay, so when we are actually making this relation, this arrow, how do you do that in the program? You put a single colon, public, which is an access specifier, which for the time being you can assume it is public, and this point is actually the name of parent class. Okay, now what happens with this? If I leave it empty, I don't write anything here, and I ask you how many data members point3d has, your answer should be 2. Why? Because when we do inheritance, when we say point is the parent of this, all of this now becomes a part of this class. You can assume that you just copy it and you paste it here. Of course, there are some restrictions. I'll come to those later. But just for the first example, you assume that when you have written this, this class is empty. But actually, it is not empty. What it has all of these functions. It has these two data members, X and Y, and all these functions, right? Because of this. But of course, we will not leave it empty. What we need to do, we'll be adding some additional data here. Okay, so let me just gain some space so that things are clear, and we can write it. Okay, so we agreed that we need 3 data members in the 3D class. We already have 2 from the parent. Okay, so when we are making point 3D class, okay, I already have X and Y from the parent. Okay, these I already have. So what do I need to add new here? I just need to add one single integer, which is Z. So now it has 3 data members, X, Y, and Z, and this is what we wanted. Similarly, in the public, I already have function for set X, set Y, get X, get Y. So I just need to add a constructor maybe, okay, with 3 integers. Okay, I'll fill it later on. And I will add a function for void set Z because it was not present in the parent. And I will also add a function get Z to return the value of Z. Okay, now if someone asks you how many data members point3d has, your answer should be 3. It has 3 data members. Okay, how many functions this class has? You just count the total number of functions in the point class plus the number of functions in the point3d class, and that is the total number of functions in it, right? So when you are doing inheritance, everything which was present here, it is a part of this class plus whatever you added new, that is also a part of it. Okay, so let me write constructor only. Okay, and then we'll write some other functions because there is plenty of details. So you might have many queries in your mind, but as I write, many of those queries will be answered. Okay, so let me just first write constructor quickly and then we discuss something. Okay, yeah. Okay, so let me just also get rid of it. Now the important thing is that how many arguments or inputs this constructor should have. We just agreed that the total number of data members in this class is 3. So this should have 3 data members as input, x1, y1, and z1. Okay, now you see there is only a single data member in the point3d class, but there are 2 others which are coming from the parent class. So the total number of data members is 3. That is the reason in the constructor I have given 3 inputs, x1, y1, z1. Okay. Now, what do we do in the constructor? Let's see, let's do what we always do. Ideally, I should be doing something like this. Okay, this is the conventional way of doing things when we are using inheritance. Okay, but if you try to run it, then it will not compile. It will give you an error. Okay, now what error it will give you? It will give you an error on these two statements. And what is that statement? What is that error? That error would be that X and Y are inaccessible. Now, this seems to contradict with what we just said, right? So we can say, okay, maybe it is giving us this error because X and Y are private, okay? But when we say we are doing inheritance, so they become a part of this. So why it is giving me this error? Okay, so now in order to understand it, let's do an example, okay? Let's for some time forget about programming and let's discuss something in the real world, okay? So maybe we take an example from the real world that suppose there's a okay, so suppose there is this car, okay, and this is generation one, right? And this is generation two. So this car actually is inherited by this. Okay, so maybe this is the parent and this is the child. So when inheritance is done, this parent is telling the child, this car is yours, okay, but this is yours, but you cannot drive it. Now you see what is happening. You are told that you own this car, it is yours, but when you try to drive it, you are not allowed, right? Means you are shown something and it is told that, okay, it is yours, but you cannot drive it. So you will say, okay, if I cannot drive it, then what is the use of having it on my name? Okay. Now on the left side, we have exactly a similar situation. We are telling the class point 3D that X and Y are yours. They belong to you. Okay. But when we try to access them, we are told that it is a private data member, you cannot access it. And this is a constraint because we know that a private data member cannot be accessed outside the class. Okay, so we are telling the class point 3D, X and Y are yours, but you cannot use it like this. So it is very similar to someone saying that this car is yours, it's all yours, but you cannot drive it. You can just look at it. So you see, it is not very practical. We need to find a solution to this so that if something is ours, if we get a car, we should also be allowed to drive the car. Otherwise, it is not very useful for us. Now, one solution could be that, okay, uh, now what is the problem? Okay, why this is not allowed? Let's just discuss in detail. We just said that if something is private, where can we access it? There are three different, we can access it in the same class. Can we access it in the child class, and can we access it in the main? Okay, so these are the three possibilities, and when I say main, I mean any other class. Okay, so it can be anything using dot operator. Now let's see what is allowed and what is not allowed. If something is private, same class can access it. Yes. From the main, you cannot access it. We already know that using the dot operator, you cannot access anything which is private. And if something is private, child class is also not allowed to access it. You just saw in the previous example, we were not able to access X and Y because they were private. Now, if something is public, what happens there? Okay, let's see. Let me just write it, okay, and then I'll explain. I'll take your queries, don't worry. Okay, so what happens if something is public? Okay, again we see, can we access it from the same class? Can we access it from the child class? And can we access it from the main? So one by one, we see what is allowed, what is not allowed. If something is public, we can access it from the same class. If something is public, we can also access it from the child class, and we can also access it from the main. Okay, we just put the dot operator and public can be accessed. Now let's see what situation we have. Now we have a point class here, and we have another class which is called point 3D. Okay, we have something private here. I write private and I write int x, maybe just x is sufficient. Okay, now we want to access this variable x here, which is not allowed. Okay, because we say if something is private, child class cannot access it. One solution could be that we can make it public rather than private. If I make it public, child class will be able to access it. But what is the disadvantage? Disadvantage is if something is public, then anything can access it. Then if we make it public, main will also be able to access it. Now you see there's a problem. If we keep it private, child class cannot access it. Means private is very constrained, very restrictive. We say, okay, let's make it public. If we make it public, then there is another problem. One problem is solved, child class can access it. But a new problem arises that if it is public, then main will also be able to access it. So as a result of this, it means that when we are doing inheritance, we need a third access specifier. Private and public are not sufficient. And what is that? I'll just give you more details later. So we will introduce a new access specifier, which is called protected. And how is it different from the previous ones, right? From the same class, from the child class, and from the main. We want something which is accessible from the same class, which is accessible from the child class, but which is not accessible from the main. Now you see, we are just, the discussion we are having, we are just trying to convince ourselves that why public and private are not sufficient when we are doing inheritance. If something is private, child cannot access it. If something is public, child can access, but rest everything can also access. So we need something new. We need another access specifier in which child can access but main cannot access, right? So this is the reason. I'll give you more details, right? But maybe you might have many queries by now. So before implementing this protected, maybe we can have some discussion and I can respond to your query. Okay, now let me just make a table to summarize this discussion. Okay, so we have something which is called public. We have something which is called maybe which we just introduced, which is called protected, and we have something which is called private. Okay, so we say same class, okay, child class, and main or any other class, right, which is not a child class. Okay, so let's see what is allowed and what is not allowed. Okay, first we talk of private. Private can be accessed from the same class, we already know, right? But private cannot be accessed from the child class or from the main. Okay, this we already know. Then we go to the public. If something is public, same class can access it, child class can access it, and main can also access it, right? We have been doing this. We create objects in the main, and using dot we access something which is private. Okay, now if something is protected, and why we need it protected? Because of this column, second column, right? Because if we make something public, main will be also able to access it. If we make something private, child class will not be able to access. So because of this second column, we had to introduce this new access specifier. So protected is something which same class can access, child class can also access, okay, but main or other classes are not able to access using the dot operator. Okay, so now this table actually summarizes. First, we saw why we need protected, and of course, I'll write a program as well. And now see that okay, uh, this table actually gives you the whole picture that what can access what, right? So same class you can access anything from the main or outside the class. You can only access public, and from the child class you can access public and protect. Okay, so this actually gives you a summary. Now suppose we are not doing inheritance. Okay, Just assume that we are not doing inheritance. So if we are not doing inheritance, then it means there is no second column. Just ignore it for some time. Okay. If there is no second column, okay, so now just compare protected and private. So you see, if I remove the second column, protected and private have exactly the same behavior, right? You see, from same class, you can access both. From the main, you cannot access anything. If there is no second column, then protected and private are exactly the same. So this is the reason that without inheritance, protected and private are actually the same thing. If you are not doing inheritance, there is actually no need of protected. This is the reason that in the first 10 week of the semester, we never talked of protected, because if there is no inheritance, protected is exactly the same as private. It is only when you are doing inheritance that there is a difference between protected and private, right? So this is something important to remember, a very typical interview question, that what is the difference between protected and private if there is no inheritance. So your answer should be there is no difference, right? And you can also say it from this illustration. Okay, now maybe we try and write a program with the information we have so far. Okay, before moving further, let's consolidate all of this, you can say, information by writing a small program. Okay, so maybe we make a class point 2D. Okay, and first I will make data private just to show you that we can access or we cannot access. And maybe in public, I'll just make a constructor and I will make a print function, nothing more. Okay, so I make a constructor point to b int, sorry, int x1, default values, y1 is 0, and then within the body I can write x gets the value x1 and y gets the value y1. Okay, now let me just make a print function. So I'll write void print to d, and here you can write cout x, maybe some space, y, and a new line. Okay, so we have this class point 2D where we just have two data members, constructor and a print function. Okay, now let's make another class which we call point 3D. So I say class point 3D. Okay, and in order to tell the program that this is child of point 2D, what do? I put a colon. I write public here. As I told you, for the time being, just write public here. We'll discuss tomorrow that why we are writing public here. And then you write the name of the parent. So the name of the parent is point 2D. Okay, so now this class has two data members which it cannot access. They belong to X and Y are members of this, but they are private, so they cannot be accessed. We'll later on make them protected. It has a print function, it has a constructor. Now within this class, I just take one data member in C and I make a constructor, say point 3D. Now I'm giving it three inputs. Okay, why three input? Because this class has three data member. Okay, now let's try to give values to X, Y, and Z. Okay, and now instantly you see it is giving us an error. It is saying inaccessible, which I told you. Why is inaccessible? So why is it happening? That although we are doing inheritance, but private cannot be accessed from the child class. Private can only be accessed from the same class. So what we need to do, one lesson is that whenever you are doing inheritance, you should keep your data protected. Now you see I have changed it to protected. Now what will happen now? Child class will be able to access it, but from the main using dot, you will not be able to access it. Now you see the error which we were getting is gone now. Now we are able to access X and Y. This is perfectly legal because anything which is protected in the parent, it can be accessed from the child class. Now let's make another function for printing data. Maybe I call it void print 3D. Okay, now one option is that you see I can write cout X. I can access it X, right, because it is protected. Y, and I can also write z. One option is this. It is perfectly fine. It is perfectly legal. There is no problem with that. But you see, we already have a function which is printing x and y in the parent class. And with inheritance, this function has become a part of the child class. So why not reuse this function? Okay, instead of writing cout x and y, we say, okay, I just keep cout z. That's it. And I already have a function which is printing x and y. So I can just call this function. Okay, one of your colleagues just asked it, so maybe this will respond to that question as well. Now you see what is going on. Let me just annotate it. This is the function we are calling, because when we do inheritance, this function is actually now a part of this class. X and y are also part of this class. Since this function was already, you can say, saying cout x and y, so rather than repeating it here, I just call this function, and for the z, I can write cout z. So now this function will print all three data members. Now, what is going on in the main? Okay, so let's create an object in the main, and it will also respond to one of the queries which were related to how data is actually set. Okay, so in the main, what we can do, we create an object of point3dp, and we pass it 1 2 3 data members. Okay, and we can write p dot. Now you see, I can also call the function print 2d. I can also call the function print 3d, because both the functions are now a member of this class. Okay, one function we have written in the class itself, and the 2d function is coming from the parent. So you can call both of these functions, right? Both the options are available. I'll just be calling 3d so that I get all the data. Now, what is happening here? Now let's see. When you are creating an object, so you see, now the class is child class. Okay, so this is an object of point3d. Name of the object is p, and it has three data members, x, y, and z. Okay, now you see, main does not know that x and y are coming from the parent. Okay, this information is transparent to the main. Main just knows that there is a class point3d which has three data members. Okay, it does not care that x and y are coming from the parent and z was the data member which was in this class. If I remove inheritance and I have x, y, and z in the same class, which is point3d, there is no inheritance, still this will work. Okay, so you see, main has no clue that whether you have implemented the class point3d with inheritance or without inheritance. It actually does not care. It just knows that, okay, there's a, when I create an object, it has three data members, I need to pass three values. Whether all three you have mentioned in the same class or you are using inheritance, it is totally, main is totally, you can say, indifferent to this. Now what will happen? You will have 1 2 and 3 here. Okay, x and y are now part of this class, and z we return. So this was only our implementation. So this is how it will look like. And we are not creating an object of the parent class, we are only creating an object of the child class. But of course, the point2d class also exists. If there's a requirement that you want to create an object of this class separately, then that you can do. Okay, it will have only two data members, x and y, in which you can give any values. But normally when we are doing inheritance, so mostly we are creating object of the child class. But it does not mean that this parent class is useless now. Parent class continues to exist independently. You can use it just as any other independent class, right? But mostly you will be reusing it in the child class, and in the main, mostly you will be creating the objects of the child class, right? So let me just show you this example on the screen. Yeah, here it is. Yes, so do you have any queries from this particular example before we extend it further? Okay, now let's do a quick recap of what we have seen so far. Okay, so we discussed that there's a lot of repetition when we are making classes point and point3d. So we say, okay, why not use inheritance, where we make point the parent class and point3d can be the child of that class. Okay, so when we do that, the class which is child class, it will inherit the data as well as functions from the point class. And what is the syntax? Syntax is that you write the name of the child class. You can call it child or you can call it derived. Both mean the same thing. Then you put a single colon. And then you have an access specifier, which I told you that for the first two lectures, you just assume it is public. Maybe tomorrow we'll discuss what will happen if we change it. And then you write the name of the parent class, which is the point in this case. Okay, so this syntax was the regular syntax. The only new thing is this colon and name of the parent class. And then you can fill this class with whatever is your requirement, right? So now this is an illustration of the concept we just saw. Child class is point 3D, parent is point, and we only put one data member, which is Z. I just add a constructor and two functions because rest everything is inherited from the parent, right? So I told you that if in the parent data is private, so if you try to access X and Y, then it will give you an error that they are inaccessible, right? So we said that, okay, although it is a child class, but even the parent class, even the child class is not allowed to access the private data. Okay, so a solution to that was that when you are doing inheritance, we introduced a third access specifier, which is a new access specifier, which is protected. Okay, so then we discuss this table that, okay, if something is public, same class can access it, child class can access it, and non-member means main or other classes, right? They can also access it. If something is private, same class can access it, but no one else can access it. So we needed a third access specifier, which is accessible from the same class and child class, but not from non-members, right? So this is the reason that we introduced this third access specifier, which we are calling private. Okay, so which we are calling protected. Sorry. So we'll be using the keyword protected now. And as I told you that without inheritance, private and protected have exactly the same meaning. And this is the reason we never talked about protected in the first 10 weeks, because we were not doing inheritance. Okay. So now you see in the parent class, you will be using the keyword protected. Okay. And when you will be writing programs in the beginning, since you are very much tuned to write private, so in the beginning, it will be difficult for you to write protected. Okay, maybe when you are attempting something, a question or an assignment. So since your mind is always tuned to write private, so in the beginning it's a bit difficult to shift to protected. Okay, so but with time you will get used to it, that whenever you are doing inheritance, we should be using the protected keyword so that we can access it from the child class. Okay, so now with that, when we make protected, now we are able to access the protected data of the parent class from the child class. Okay, okay, now what we'll do is we'll just see some more, you can say, without writing some detailed program, we'll just try to develop our understanding by looking at some different examples. Okay, so suppose we are dealing with geometric shapes. We have a class polygon, which has a width and length, and we have a set function. Okay, so this is for the polygon class. Then we have a class rectangle, which also has a width and length, a set function, and area function. And we also have a third class, which is triangle, which again has a width and length, a set function, and area function. Okay. Now you see, there's a lot of, you can say, stuff which is common in the polygon class and the two other classes. And we also know that every rectangle is also a polygon. Okay, every triangle is also a polygon. So logically also, we know that rectangle is just a special type of polygon. Triangle is also a special type of polygon, right? So you see the highlighted part. This is the part which is actually common. So we say, okay, why not use inheritance and reuse this from the polygon class so that we don't have to write it again in the child classes. Okay, so the first thing we do is we write our polygon class, but we have to change one thing. We change our data from private to protected so that we can do inheritance. And now what we'll do, when we'll make the class rectangle, we will make polygon a parent of this. So now everything which is here comes here. So I don't need to have again integer width and length. I don't need to have the set function because that is inherited. The only thing I need is area function in this class. Okay, so when we do inheritance, so we will put an arrow which is pointing from child towards parent. And actually this which you see on the left side, this is same as this. Okay, because everything we have just pasted here, and we have this area function. So both of these are actually equivalent, what you see on the left side, what you see on the right side, but we avoided typing it again. Similarly, we can do the same thing for the triangle class, right? That instead of repeating everything, we say polygon is a parent of triangle. So again, in the triangle class, I will just make this area function, and rest everything is coming from the parent. Okay, now one important thing when we are doing inheritance is that you see, you can call it a parent class or a base class or super class, all mean the same thing. Okay, so when data is inherited, so data and functions, they are inherited from parent to child. Okay, but please remember, nothing from child to parent comes here. Means if there is something C here, you cannot access it from the parent class. Okay, means it is one-way traffic. Things, when I say things, I means members, data members and member function. From the parent, they go to child class. But nothing the child class can be accessed from the parent. So it is one-way traffic. Okay, so please do remember that. And you see, it can be slightly confusing that when we say members are going here, we put an arrow like this. Okay, means from parent things are going here. But when you draw the UML notation, the arrow is actually reverse. Okay, the arrow is pointing from child to parent. Okay, so please be careful about it, that in the composition as well, when you are making the UML diagram, so this diamond is on the container class. Okay, similarly, when you are representing inheritance in a UML, arrow is pointing from child to parent. Okay, it is not the other way around. Okay, now let's test our understanding, and I'll show you a program, and then maybe I'll seek your feedback. Okay, we have a parent class in which what we have done, we have every possible access specifier: protected, public, and private. Okay, so we have X and Y in protected, we have a function in public, and we have another data member Z, which is private. Okay, then we make a child class. Okay, child class has a data member A, which is private, and a function which is public. And let's write the body of the function. So this is the body of the function. Okay, so now just look at this body of the function and tell me which of these are legal statements and which will cause an error. Just look at it, and then you can tell me, then we discuss. Okay, yes, please. Can you identify if everything is fine in this function, or there's some issue with that?
Sir, the Z cannot be, accessible here.
Okay,
It's
and
not
what is the
accessible
reason for that?
because it is in private section of
Yeah,
the.
yeah, very good. You see, let's do it one by one. X and Y. What are X and Y? They are protected data members of parent, so they are okay. We just said that protected can be accessed. Here we are calling set function of the parent. What was set function? It was public. That is also okay. Here we are accessing the data member A. A was a private data member, but it was of the same class. So from the same class, we can access it. That is also okay. But now you see this one, here we are trying to access Z, which was a private data member of the parent. So this Z is not accessible. So rest all the statements are okay. This last statement will actually cause trouble. Okay. Now I show you another example, right? Just look at it and then think what, if there's any problem in that, or is it okay? There's nothing much in the classes, so maybe you have to look at the main, because classes are pretty straightforward. Okay, good. So I got a few responses in the message window. Yes, all of you are correct that the problem lies here, right? We cannot access X and Y because from the main with the dot operator, you cannot access protected. Okay, with the dot operator, you can only access public, nothing else, right? So this is where the problem lies. So very good. Okay, now let's see this one. Let's think over it and then tell me. Okay, so in this case, I think it's fine, right? Because X and Y, they are protected, so we are accessing protected in the child class. This is okay. In the main, we are just creating an object. So this program is fine. There is no problem with that, right? Sometimes things can be okay as well. It is not necessary that there's always a problem, right? And then this one, you see it is similar, but it is private. So we are trying to access private in the child class. So this is where the problem lies, okay? Private data cannot be accessed from the child class. And then last one, the data is private, but we are actually not accessing it directly. We are using the set function, which are actually public. Okay, so again, this particular piece of code is fine as well. There's no problem with that. Okay. So maybe I'll stop here. I just have two pending queries to respond. So let me respond to them and then we'll conclude for